Hello. I wanted to add a brief supplemental video, as I've done some of the other weeks, introducing the DW Mini Project. The DW Mini Project is very similar to the PW Mini Project. In fact, the first three questions of the DW Mini Project, summary statistics, most common item, and items by region, exactly replicate the entirety of the PW Mini Project. The notable difference is that in DW, you are expected to use pandas. There is a slight, maybe misleading note here. It says we'll be working with the same medical data as used in the PW Mini Project. This is not quite accurate. The very first cell is for downloading the data. And you can see it includes many wget commands which do download the data. After running that cell, you should have a DW directory in addition to your old PW directory. In the DW data directory, there is a 2017 and a 2016 scripts CSV. Most of the mini project will be done working with the 2017 data in the DW data directory, as well as practices chem, and one question also works with the 2016 data. Note that if you are working through the mini project and are working with the PW data, you will not get correct answers even for the first three questions. Even if you were to use the same exact code for PW that you used in PW. So be careful that you are using the correct DW data. Similarly to the PW mini project, since we're using the same data set, though a slightly different sample from it, the same kind of concerns about ambiguities apply to the DW mini project. In particular, I want to remind you that, for example, the practices, your practices table will have duplicated practice codes with different postal codes associated with them. If you perform a join of the practice data to the prescription data, the prescriptions will be duplicated based on each match found between the practice of a particular associated with a particular prescription and each practice code found in the practices table. You'll first need to remove the duplicates from the practices table before joining it to the scripts table, or else you'll end up duplicating prescriptions before doing any of your statistical calculations. That'll throw off your calculations since you'll have scripts showing up multiple times, perhaps contributing, multiple counts or multiplier effects against the number of items prescribed. I wanted to also provide a few pointers for some of the questions. For the script anomalies question, we're asking about drug abuse and are particularly interested in practices which prescribe high percentages of opioids. We provide a list of names of opioids. However, if you are working with the chem table, you will probably find that, for instance, there are few, if any, drugs called morphine in that table. However, you may find drugs such as dimorphine. That is also an opioid. You should be searching for any drugs which contain any of these strings as substrings in the drug name. you may want to look at the Pandas user guide for working with string data or working with text data for advice on how to look for substrings in a Pandas series. The script growth question is the only question where we make use of the 2016 data. Note, in both script anomalies, question 4, as well as rare scripts, question 6, we ask you to calculate z-scores. You may have to think about how you're going to calculate the standard errors for the z-scores in these two different problems. There are some hints or directions in each question that should help you calculate the standard error. In the script anomalies question, calculating the standard error is fairly straightforward and follows the kind of instruction or the formula introduced in the statistics lecture. However, for the rare scripts question, it says we will estimate the standard errors by taking the standard deviation of this difference. Remember that the standard error is the average deviation of a sample mean from the true mean. In some case, we can calculate the standard error based on the central limit theorem, but in some cases, this is not possible. However, we can, if we have many samples, simply estimate the standard error by calculating the standard deviation of those sample means. That method is what's being suggested here in question 6. Also, I want to note that in many different points in both PW and DW, we ask you to express things as percentages. Again, this is unfortunately a bit of a misleading instruction. So for instance, we have here amount dispensed as percent of total. But down here, we have a proportion. This is not 0.03%. This is 3%, represented as a proportion out of a maximum of 1. Unfortunately, it's perhaps a bad habit of mine to say percent when I mean proportion. So another thing to be on the lookout if you're confident that you are calculating the solution correctly, but for some reason are getting a low score. You may, if your answer involves percentages, you may want to change those to proportions by dividing by 100. That covers the basis of a lot of points where people get confused or stuck or encounter difficulties with the DW Mini project. Of course, as always, I'll be answering questions as you ask them about the DW Mini project in office hours as well. I also wanted to provide a brief comment that in the statistics lecture, we truly provided just an introduction, mostly to help with some of the questions in this project where you calculate z-scores and provide a bit more context, as well as to prepare you for Unit 2, where we'll discuss more about statistics and machine learning. In the statistics lecture, I pointed out several times where there were more advanced statistical topics that should have been taken into account based on the examples I was discussing. But I wanted to mention in particular that while we focused on means in the statistics lecture, we can also calculate all kinds of and do statistical tests and inference on all kinds of statistical quantities, including variances and standard deviations, correlations, and proportions, which themselves are basically means. So that introduces the DW Mini project and wraps up the lectures for this week.